the following question with respect to submanifolds. Does a smooth map remain smooth if we restrict them to submanifold? So let's say F is a smooth map between smooth manifolds N and M. We split the question into two cases, so restriction of domain and restriction of codomain. In the domain case, we assume that S is a submanifold of N, and we ask if the induced map, right, on S, restriction map from F to S, this map F restrict to S, is still smooth. In the codomain case, we let T be a submanifold of M of the codomain, and we ask if this induced map is still smooth. Now this domain case, the answer is obvious. It's gonna be yes. And why is that? Because this inclusion map, whether S is an immersed submanifold or an embedded submanifold, this map, it's gonna be smooth, just by definition of submanifold. And a composition of smooth map is always smooth, so this restriction map is always smooth. So we only want to look at this question about restricting codomain. Intuitively, you might feel, how could restriction of the codomain change the smoothness of the map? It's just intuitively, it really feels like this should be smooth, but it's a little more subtle. If this submanifold is an immersed submanifold, then this might not be smooth. If it's regular, then this is indeed smooth. So let's look at an example of an immersed submanifold to see that this restriction is not smooth. Let's look at this map that we have encountered before that wrap this interval into a figure 8 inside R2. So it goes as follows. On this part is from pi over 2 maps to the origin, okay? And then from there, if we go left, then this maps to up here and go around here. If we go right, then it maps here and go in this direction. So basically wrap this interval here and this interval here. Now let's see why this is not a smooth map if we restrict the codomain to just this S, this figure 8. Now let's take this green interval around the origin. That must be an open set of S under, if we use the topology of the immersed manifold, because it's the image of this interval, right, and also the image of this interval, for example. It's the image of the union of these two intervals, for example, and these are both open, so this is open. However, its pre-image though contains this point, also contains the point pi over 2, and that's an isolated point, so its pre-image is actually not open. Thus this, if we restrict to the codomain, then the map is not even continuous. So how can it be smooth? Originally, when the codomain was the whole of R2, then the neighborhood of the origin would be like this, would be a disk like this, right? And then the pre-image of that then would also has to include this piece, so it will also include a neighborhood here of pi over 2, and now the pre-image is open. But if we only restrict the domain to S, then the pre-image does not contain this part here anymore, so suddenly we have an isolated point and the pre-image is no longer open. Okay, but that's the only problem possible. So the only problems that can arise are with immersed submanifolds. We claim that if we restrict the codomain to a regular submanifold, then that's fine. Okay, so let's assume that the image of F lie in some regular submanifold T of M. Now we want to show that this F tilde, this induced map, is smooth. Now to show that this map is smooth, we just want to check that it's smooth in coordinate. Since T is a regular submanifold, at every point P in T, we can find a coordinate chart such that T is cut out by coordinate functions. So let's say that at a point Fp here in T, we choose a coordinate neighborhood U with coordinate function y1, ym, so that T is cut out by yr plus 1, dot yr, ym, and so on. In particular, these y1 to yr form a coordinate chart at T. Now to say that the original map F is smooth means that it's smooth in coordinates, so that means that this map, if we compose it with this chart, is a smooth map from N to Rm. But now observe that this induced map is just the combination of this map with the projection. I should say the coordinate version of this map. So if we write this in this coordinate, then it just corresponds to this map combined with projection from Rm to R to the R. And this is smooth and this is smooth, so this combination must be smooth. So that means that F tilde is smooth in coordinate, and thus it must be smooth. Thus we see that if we restrict the codomain of a smooth map to a regular submanifold, then the resulting map is still regular.